enthusiasts by providing cutting-edge technology information, technical courses, seminars, workshop, hackathon, startup competitions, and industry recruitment. And we are committed to closely connect community members to jointly build the future of Web3. TinTin Meetings and online live broadcast program we set up, focusing on the field of blockchain technology, inviting technical leaders in the industry to explore the practice and innovation of blockchain technology with everyone. DePIN represents an important application breakthroughs of blockchain technology in the physical world. So by combining IoT devices, sensor network sharing, economy, and other fields with blockchain, IoTeX is committed to building efficient, secure, and scalable decentralized infrastructure in this field, creating a new future where everyone participates and shares economic value. So in this TinTin meeting, we especially invited Giuseppe, the head of the IoTeX developer relations, and Simone, head of IoTeX developer relations department to discuss IoTeX and DePIN in depth, starting from the basic concepts and gradually expand the registration process, set up the sets and operation guides. We will deeply analyze how IoTeX can promote this vision of everyone participates in DePIN globally and work together to create a decentralized future. So today we have two parts, but you can see from the poster, first of all, we do the workshop, and after that might be have a QA, but based on like the Tuesday, Giuseppe said, like if you want to get a deep like detailed response, so we can gather all your questions. You can just drop it here, or like on YouTube, we'll gather it for to them. So yeah, just let's start it. Let's welcome. We're honored to invite Giuseppe, yeah, and Simone. So yeah, please
Sweet.
go ahead.
Awesome. Thank you. Thank you for having us. All right. Let me just see here. Okay. Awesome. Well, thanks for having me again, and I'm here today with Simone, who you haven't met yet. Yeah, like we were saying on Tuesday, I actually enjoyed some of the questions that you guys shared. So I'm trying to post an answer every day or something around that range. I think if that's okay with you, I can maybe share my screen and we start introducing DePIN a little bit, what IoTeX is doing, and then I'll pass the ball to Simone, who is going to basically show all the components of like a DePIN application in more detail and basically run this workshop on how to build like an end-to-end application, and then maybe we do some Q&A afterwards. Does that sound good to you guys?
Yes, yes.
Cool. Awesome. Okay, so I'll go ahead and share. Here. Okay, I think you guys should be able to see this now, right?
Yep.
Awesome. So I'm just gonna go away and present. And I think you guys can see, right?
Yeah. Yes.
Awesome. Sweet. So again, thanks TinTinLand for having us. My name is Giuseppe, and with Simone, we're part of the DevRel team at IoTeX. If you want to follow us to learn more about what we're doing every day, besides like the official IoTeX channels, Simone is Zimne and I'm DePIN Jesus, and we also run the IoTeX Dev account, where we normally just focus a little bit more on the technical content. So for developers, builders, or maybe enthusiasts that just want to know a little bit more like how or what happens behind the scenes in a DePIN application. All right, so I wanted to quickly introduce IoTeX and what IoTeX does. IoTeX provides a modular infrastructure to build DePIN applications, just like we talked on Tuesday. So what does that mean? It means that basically, as we will see in a few minutes, DePIN applications has various components IoTeX provides a sort of like a cohesive infrastructure that puts all these components together. But and some of these components are provided by like third parties, and some of these components are provided by IoTeX in-house. And the most critical components of a DePIN applications provided by IoTeX are the DePIN blockchain. That's the IoTeX layer 1, which is a super fast EVM type of blockchain. We have a TPS of max TPS of 1000, which is great. We have full Ethereum compatibility, and we have instant finality, 5-second block time, and I think we have passed the 100 million transactions a while back. So the IoTeX layer 1 is fantastic for DePIN. We have another infrastructure components that's called IOID. That is a protocol to manage the DePIN identities, which means basically the identities of like the machines involved in a DePIN network, the devices, the owners, so the contributors to this DePIN network, as well as the identities of basically a project as a whole within the infrastructure. And then we do another component that is called WebStream, and that basically handles the verification of DePIN. Because as we will see in just a few minutes, DePIN verification ends up being one of the most crucial components of an application, and we'll find out why in just a second, even though we brushed upon it on Tuesday. So I've introduced DePIN on Tuesday, but let's just do a little refresher for everybody that maybe hears this word for the first time or maybe is not too familiar with it. As you can see from this slide, there are a ton of applications that are involved into the DePIN landscape. DePIN stands for Decentralized Physical Infrastructure Networks, and it is essentially a special set of applications that facilitate a token economy for basically for people or participants to provide infrastructure and run an infrastructure. And this token economy basically incentivizes people to do so. So there are two main parts in a DePIN application. One is the off-chain infrastructure, physical infrastructure part, and one is the on-chain token incentives and business logic. Now, one of the coolest things about DePIN is that finally it's basically putting together the physical world and the on-chain world, which is great because we're seeing a lot of like these real world based applications that are just like beyond just the world of Web3. So we're not like siloed in our own Web3 world anymore, but we actually can build applications that provide some like real world utility. And that is fantastic because I think it's basically one of the ways that finally Web3 is opening up to the general public and to mass adoption, which is great. So that is great. At the same time, this sort of like physical, real life and blockchain type of dynamic in DePIN projects also represents a huge issue in a way, because essentially, how do you trust that something, and I brushed upon this on Tuesday as well. So how do you trust something that comes from the physical world to trigger some sort of like financial incentives on the blockchain? And when we were talking about this on Tuesday, if you think about it, like when you have like DeFi applications, for example, you basically, everything is on chain. So everything is like trustless and everything can be sort of like checked on chain. But when you talk about DePIN, how do you make it so that the physical world can somehow be verified? And this data can be verifiable by smart contracts that's on chain to trigger like a financial incentive. And especially when you add financial incentive to this data, then obviously that becomes one more reason to try to spoof the network in any way. I forgot to say one thing. So if we go back here, just to give you an idea, right? to understand more DePIN, perfect, the most maybe famous example of a DePIN application is Helium. And Helium, basically, it's a physical infrastructure of like these routers that provide connectivity. So they provide a service for end users. And people that run these routers are rewarded on-chain with like, the Helium token. And like Helium, we've seen other large applications like Demo, for example, that's in the mobility sector, various weather-based applications like WeatherXM, for example, where basically people are rewarded to provide data through these devices within the network. And so what I was saying earlier is like, how do you make it so that like, an on-chain, basically smart contract can trust like the physical world? Normally, the way it's done basically almost in every case at the moment is done through a centralized cloud backend. So what does that mean? It means that if you look at this slide, on the left side, you have this like network of physical devices. On the right side, you have these like smart contracts that basically and like these tokens that are used to like reward data contribution. And then, so these are sort of like the two decentralized parts on the opposite side of the spectrum. And then in the middle, all applications at the moment basically orchestrate this communication and orchestrate this business logic within a cloud infrastructure. And obviously, while that is okay to like begin with, it poses various problems. Like DePIN applications are not really composable at the moment. They're not really trustless, but you really have to trust the single entity that runs like, a certain DePIN project. And it's hard to also have these applications be interoperable, meaning like basically talking to each other in any way. So each DePIN is sort of like siloed at the moment. So the point of IoTeX is to actually decentralize this central part here, this cloud backend part, and propose these basically 9 layers to decentralize the whole stack. If you look at this slide and you think about basically data, let's say, coming in from the top of the slide, from your devices, then we identified and provide this like hardware abstraction layer that connects with like this connectivity layer, sequencing to pack all this data together, store it in some sort of like data availability layer, have this data being computed in an off-chain computing network that does basically verifiable computation. And Simone will dive into that in more detail in just a sec. And then finally orchestrate the token rewards on-chain and issue these, transfers. And then on the left, you see these like 2 vertical sort of like protocols that basically are used throughout the whole pipeline. And one is the identity protocol that I was talking about earlier, and like governance layer in case of like, DAOs or decentralized basically communities and things like that. So what I'm going to pass the ball to Simone now. And what Simone is going to talk about is basically how do you spin up these like services, and is essentially going to focus more on the identity part, on the off-chain computing part, and then on the blockchain layer where we'll have some smart contracts that basically puts everything together. So I'm going to stop here. I'll stop sharing, and I think, Simone, it's all yours now. You are muted.
There we go. Let me try to share the screen as well.
Also, I don't know if there are maybe questions about what I just spoke about, or maybe we do them towards the end.
Yeah, we can do this towards the end if there are
towards the
questions.
end. Okay, cool.
Yeah.
All right, Tracy, all good.
Can you see my screen?
Yes.
Okay, cool. Yeah. Hi, everyone. Thank you for joining this workshop. Yeah, Giuseppe took you through a high-level introduction to IoTeX, and what is a DePIN, what are the challenges of DePINs, and why. Yeah, actually, let's focus a little bit more on why we need all these layers to create a DePIN application. So, as Giuseppe said already, when the main problem of a DePIN is how you actually, not you, but how your DePIN smart contract, your DApp, who is supposed to incentivize people to deploy and maintain an infrastructure in the physical world, how this DApp can trust what's happening in the physical world and actually confidently distribute these rewards on chain to the actual owners of the infrastructure nodes based on how they are maintaining this infrastructure and how much work their part of the infrastructure is doing in the physical world. So usually the easiest way would be to just have a cloud infrastructure, typically an IoT system that runs on a cloud where all the devices that make up the infrastructure are connected to this cloud, sending data to this cloud, and then the cloud would just manage everything off chain, and the smart contract would just trust that cloud server to trigger whatever rewards to whoever the cloud says it should be distributed. So obvious problems of this implementation, that's how basically any DePIN project is implemented today. The main problems are that this implementation is not a Web3 application. It's basically a Web2 system that, of course, is not trusted. And of course, it's not composable with other on-chain applications, for example, DeFi applications, right? So how can you do it without having a cloud? Basically, you have to decentralize all the services that these cloud systems are providing for the DePIN application. And these services can be identified for a DePIN project into, we have identified these layers to decompose the centralized services into a decentralized infrastructure. So starting from the hardware layer, you have a hardware layer that interacts with the hardware itself. So that's what is typically called the firmware part, and it's more IoT development, right? And then you have some hardware. Think of typical DePIN application as an example. For example, Helium, or Demo, or any, let's say, a decentralized Wi-Fi infrastructure that is incentivized by the blockchain. Usually the hardware is a Wi-Fi access point that people are incentivized to deploy, connect, and provide Wi-Fi service, and then get rewards on chain. So you have this hardware piece of the infrastructure that communicates some information about the service that it's providing to the users. For example, could be, okay, I am this device X, Y, Z, right? And today I provided, so much network coverage, so many, I've served so many clients for so long time, whatever, right? Providing this information. This information should make its way up to the smart contract to decide how much and if the owner of this Wi-Fi access point should be rewarded. So this device is typically going through some connectivity, for example, HTTP or MQTT, to send this data to a server. So this server we call it a sequencer. The sequencer is typically the service that receives the data from the device and does some validation. For example, authenticates the device, validates the data to see if it's consistent, if it if the quality of the data is right, and then it packs together these data messages in a data block and places these data blocks somewhere. We call this next layer, a data availability layer, right? And that's where these data blocks are stored before they can get processed by the next layer that we call the off-chain computing layer, which fundamentally fetches the data blocks from the DA layer, the data availability layer, and process this data to somehow identify what the devices are doing, right? So if they're working correctly based on the data that they produce, if they're working correctly, if, I don't know, whatever like DePIN logic you want to run on top of the device data. And finally, the main role of this layer is to generate a cryptographically verifiable proof of what happened in the physical world to these devices, basically what these devices are doing. Generating a single proof on top of an entire block of data also allows for data scalability for a DePIN application. So the data don't have to make their way directly into the smart contract. That would be not scalable for a blockchain. Instead, they get packed and computed off-chain by an off-chain computing layer that generates a single verifiable proof that goes to the blockchain. And then on the blockchain, your DePIN DApp contract would just have to verify this proof and then process whatever the output is of the off-chain computing layer, for example, to distribute incentive rewards to the owners of the devices that actually behaved correctly in the physical world. All these layers should be decentralized. Not all of them today are decentralized because the Web3 technology is still progressing into the research aspect of how to decentralize the connectivity, how to decentralize the sequencing, how to decentralize data availability. For some of these layers, there exist decentralized networks. For some others, there are no options, not decentralized options to date. However, it's possible to decentralize many aspects of a DePIN project. So yeah, let's get a little bit more into the details of how you would design a DePIN proof of concept. Yeah, let's say. So how these layers translate in an actual architecture for a possible proof of concept for a DePIN application. So yeah, let me clarify that the time is not enough to implement a working DePIN project, of course, in 45 minutes. If it would be so easy, right? There would be a lot more DePIN projects decentralized out there, but we can focus on some crucial aspects, right? I'm assuming that many of you are already Web3 developers, so they know how to create and deploy a smart contract on chain. So these are the two parts of a DePIN project. You have a non-chain, a blockchain part of your application. I colored in green all the components of the DePIN project, and in light blue all the components of WebStream, which is one product, one infrastructure that we provide. And and this purple pink color represents IOID, which is another infrastructure that we provide. And I'm assuming that the blockchain is, of course, the IoTeX blockchain. So let's go through this architecture, simulating how it would work, right? So you have a physical infrastructure that's the lower part of this architecture where you see all these devices. These devices could be whatever infrastructure you are trying to incentivize, right, or to decentralize with on-chain incentives. So if it's a decentralized Wi-Fi or a cellular network, this would be Wi-Fi access points, or could be 5G antennas, or could be weather stations in a weather data infrastructure, or could be, I don't know, autonomous cars, autonomous drones, whatever type of utility you want to provide with this infrastructure. The device will change accordingly, right? But regardless of what the device is, this device is communicating some data to your application, or at least should provide enough data to prove to your smart contract what is happening in the physical world, enough to be able to distribute rewards, or even more data if your on-chain DApp needs more data to, I don't know, if it's a game, I don't know, or if it's whatever financial application, right? Any additional data should be sent out from the device. This data is going to, in this case, it's just a service that, because there are no like decentralized data sequencing infrastructures out there so far, not specifically for DePINs, right? There are some for scaling EVM blockchains, but these are very specific use cases that do not apply to DePIN. So assuming this one is going to be a service that you can create, and we provide some examples, implementations. So the role of this service is going to be to receive the data from the device and hack this data in what we call a web stream task. A web stream task is basically a block of data with some metadata inside. And so this block of data is then stored into a DA layer. So there are multiple options for DA layers out there, decentralized DA layers out there. However, for a proof of concept, we are going to use a simple Postgres database that is publicly accessible from WebStream, right? So let's say that the data streaming and sequencing and data layer basically are implementing like these two like connectivity and sequencing, right? And Postgres is providing the DA layer. So next, we need something to act as an off-chain computing layer. So something that can process the data blocks to generate a proof for our DApp on depending on whatever we want to like prove to our application. So for this type of service, we built WebStream, which is a decentralized off-chain verifiable computing that is based on zero knowledge cryptographic schemes. Not sure how many of you are familiar with zero knowledge proof generation. There are different frameworks to like basically compute some data and generate a cryptographic, let's call it signature, right? Or more generically, cryptographic proof that proves the computation that has been performed on the input data, and additionally generate some output. So basically proving that output has been actually generated by a certain set of input with a specific algorithm. So this is what a zero knowledge like framework can provide. WebStream allows you to deploy these ZK logics to a decentralized network of prover nodes and use it into your DePIN application to compute on top of the data from your devices and generate a proof for your smart contract to distribute rewards or to run whatever on-chain logic it's supposed to run. So typically the flow is that your device sends data to the streaming and sequencing layer. The streaming and sequencing layer validates the data, packs them into a data block and stores the data block on the data availability layer. In our case, it's a Postgres database. Then WebStream would fetch every new block of data, pass it to your proving ZK proving logic, and send back the ZK proof. Well, actually not to the DA layer. That's a little bit confusing here, but eventually it's sending the ZK proof to the blockchain. So it's not sending it to your DApp yet. It's sending it to WebStream on-chain contracts that will do some more like logistic on the proof, verifying the node who generated the proof, and some like WebStream, token economy. And then eventually the WebStream router contract would send this ZK proof plus the metadata to your smart contract. And typically your smart contract would verify the proof, access some like identities on chain, and then finally distribute some incentives. So yeah, as I anticipated, while it's possible to build a DePIN proof of concept quickly if you have a good tutorial, it's anyway made of many components, and you should understand all the components that make this design, this architecture. So today I'm just going to focus on this off-chain part and just give a quick look at a possible DePIN app contract, how it would work. I will very lightly go through the identity part, but you're totally invited to check out our documentation and join our Discord to start building something and ask questions and seek for help, because anyway, this is all a little bit in development, in beta, and yeah, any contribution is also welcome. So let's move to the actual documentation portal, which is accessible at docs.iotex.io. In the IoTeX documentation portal, you have some introduction. There is the white paper that I highly invite you to read, because it's like a wealth of information and knowledge about DePIN and the state of the art of DePIN technology and architectures. And then we have some documentation about all the different infrastructures that IoTeX has built. So there is the layer 1 documentation. I'm not going through this one. As I said, I'm assuming you are a Web3 developer, so you're familiar with EVMs, Ethereum development, Solidity. Then there is the explanation of the IOID, which is our solution for decentralized identity management that allows a DePIN project to register device identities and owners on-chain and manage these operations both on-chain and off-chain. And then WebStream, here is where you find the documentation for WebStream. That's what we are going to focus on, right? This component here, which allows you to basically prove the physical work to your smart contract. So what you want to do usually is to, let's say, let's get started here. Yeah. So what you want to do is to build a sequencer, have a DA layer ready, and deploy some proving logic to this infrastructure here. Now, to get started quickly, we provide a development environment where you can easily spin up a simple sequencer, a simple Postgres database to act as the data layer. It spins up like a single node web stream network, which is made of what we call a coordinator node and a prover node. And this allows you to send a test message, like let's say a simulated message as if it was a device message, to this sequencer and get out. After you send out enough messages to pack like a whole block of data messages, then you should be able to see WebStream fetching this data block and generate a proof according to your WebStream or your ZK logic. So it's pretty easy, actually. Let's actually go through this quick start. So I don't know if it's too small. Let's make it a bit bigger. Okay, so yeah, let's go through it. So first we create whatever folder for our project. I'm calling it WebStream. That could be probably the name of your project. We need to, so in this getting started, I'm not actually going through creating a ZK logic. Rather, I'm downloading a ready-made ZK logic that implements a simple range prover, which is basically proving that a certain number is within a certain range of numbers. So, and then later I'll show you how to get started creating your own logic. So to save our WebStream logic, we need a folder, test project, okay? And we need to know what's the latest release for WebStream. So I have a simple command here that tells us that just fetches from GitHub the latest WebStream release, and you can actually see it. It's 0.12. Okay, now that we know what's the latest release, we can fetch one of the 3 demo examples. I'm fetching the one that uses the RISC-0 like built example. So WebStream allows you to create your proving logic using different ZK frameworks. You can get started if you're not familiar with ZK, starting with a ZK virtual machine framework like RISC-0 is an excellent option because it allows you to create your logic using a standard programming language like Rust without caring about how to create an actual ZK circuit or all the complexities behind generating a ZK proof. So I'm downloading this example here. And it's inside the test project folder. That's the file with the example. Yeah, let's take a quick look at this actually, this example file by code test project 10,000. So that's the typical, I cannot move it. That's the typical project file for WebStream that contains your logic. This is like the binary code of your actual ZK logic. And it contains some settings like how this logic, what framework has been used to generate this logic, and where the ZK proof should be sent after the WebStream network has generated a proof, right? Where this proof should be sent. So in this case, I'm just leaving standard out so that we can see the proof generated in the console. So that's the, yeah, we have the source code for this range prover example on the WebStream repository on GitHub. Okay, now that I've downloaded the example, what I can do as a developer, I want to spin up the whole development setup, which is, where is it? Yeah, which is basically this setup here, right? I want to spin up a demo sequencer, a Postgres database, a single node WebStream prover to basically test my project. So what I do, I fetch a Docker Compose from our repository, right? So I have a Docker Compose here. If we take a quick look at this Docker Compose, just to confirm what it contains a few like images, like a sequencer, right? The coordinator node, some provers that implement the different like proving frameworks, and a Postgres database to serve as our like data layer. Okay, so I can just do like Docker compose app to start all these like services. Okay, so we see basically the log for all the different services, right? And the sequencer, the coordinator from WebStream, and yeah, the database and so on. So we have all the services ready for starting our development. I'll open another terminal, one more terminal. Okay, so basically I have the whole WebStream testnet running on my computer, plus I've started like a demo sequencer and demo data availability I can start from these ones to start developing my DePIN application, right? But I can start using them as a demo application to receive data messages and pack them, store them on the data layer, and then generate a proof. So I can focus on the web stream proof development. Now, as I said, I'm not going through creating the prover. I'm using a prover that I have already downloaded, like the one that does the range proving. So what I can do, I can just send a test message to the sequencer. So this sequencer is configured to pack together one single message and pass it over to the web stream network to basically prove that the data contained in the message respect the range prover algorithm. So let's actually take a quick look, right? Okay, so what I'm doing here, right? I'm sending this message, right, to my local host sequencer, to my sequencer running on the local host in the /message endpoint. That's the endpoint of the sequencer to receive data basically from the devices, the DePIN devices. So I'm simulating a DePIN device, sending the data. And the data for this demo is basically one input, which is an integer number, and a range. So two inputs separated by a comma that represent the range. And our prover will basically provide a proof if this first input is actually included in the range. So I'm sending out this message. And now basically you can see the log from the RISC-0 prover in WebStream that has started basically computing the data block. In this case, the data block is just one single message because that's how the sequencer is configured, to just pack together a single message and send it over to the WebStream prover. That's not ideal for scaling, but it's quick for development. So basically you see the ZK proof, that's a RISC-0 ZK proof generated by WebStream and visible on the console. That's because the demo project is configured to output the proof on the console, right? So one quick thing we can do here just to modify it a little bit, we can edit the configuration of the sequencer. So the sequencer, the starting command, we can add an additional parameter here called, we can call it aggregate. I'm not sure I remember it, but should be aggregation amount. And give this a value of, say, 3, right? Okay, hopefully I remember the correct parameter name. So this demo sequencer allows you to configure some parameters. Yeah, and one parameter is how many messages you want to pack together in a data block, which is the aggregation amount. So let me restart the whole stack. Now, if I send a message to the sequencer, it should not do anything. Instead, it's doing it, and probably that was not the correct name. Let me quickly find it. Okay, that's, by the way, the repository for WebStream, where you also find the source code for the sequencer. There should be one setting that is aggregation amount. I was correct. Aggregation amount, which is default 1. Oh, I see the error. Okay. Usual live workshop issues. So I should have added the dash for the arguments. Okay, restarting services. I think it should be running ready. So let's send one message. Okay, so as you can see, the sequencer has received the first message, but because I've configured it to pack together 3 messages in a data block before sending it to the WebStream network, it's just waiting. So I can send one more message and a third one. Now that I send a third one, it will actually generate a WebStream task with 3 messages and send it to the WebStream prover. And then now WebStream is computing a proof for range proving over all 3 messages, and then generate a single proof for the entire block of 3 messages, proving that all 3 of them actually respect the fact that the input is within the range. So yeah, this was just to get you started on how you can, yeah, basically initiate the development of a DePIN project that it can provide verifiability in terms of the DePIN logic. Now, how would you, here is the proof, how would you like progress from here? The first thing would be to deploy actually your project to the WebStream testnet, right? Because we have been building it locally. And next, to configure your project to send the proof to your contract and then build your actual contract. So of course, we're not doing it now, but I just want to take you through where you can find these and just to get started. So basically, next step, yeah, would be you start building your proving logic, right? So in the documentation, you have like build the prover code, right? So how you actually generate a project file for WebStream. So assuming you want to build your demo using RISC-0, you can go here and see how, well, you should also be familiar with the actual RISC-0 development process, but it's everything linked here. So you can follow this simple guide to create your own WebStream logic. And then there are like the steps how you actually build your logic and generate the project file for WebStream that actually sends out the proof to an Ethereum smart contract. And finally, how you deploy this logic to the actual like public testnet for WebStream. And then next step would be you start building your on-chain contract that actually receive this proof, verifies it, and yeah, sends incentives out. So before I stop here, just want to point you to like this building DePINs under the builders part of the documentation. Here we are going to publish an end-to-end DY demo. It's still in progress, so I would like to invite you actually to register to our newsletter. I'm going to show you where, because we will notify you when this is ready. But basically, this one is taking you step by step into creating an end-to-end working decentralized Wi-Fi network, physical network, even using real devices to act as Wi-Fi access points. This is already built, but it has to be updated to the latest version of WebStream. So yeah, I would really love if you guys register to our newsletter. If you go to the DePIN incentives contract, you can see an example how a smart contract would actually receive a proof in this function, would receive the actual proof from WebStream in the data field, decode it, and then distribute rewards based on the output. Not going into the details because it's really even though if it's a proof of concept, it's anyway a little bit complicated to explain in short. Actually, a good idea is to go to our, let me move, to go to our developer portal, developers.iotex.io, and subscribe to our newsletter here, and you'll get notified when the end-to-end demo is ready. And here you can also quickly get started with setting up a MetaMask, getting IoTeX test tokens, and start building something or experimenting, at least with our layer 1. I'm stopping here because there is a lot, of course, to say, but would require a few days workshop. So passing over to Giuseppe again. Let me.
Yes. Let's see, maybe I can share this slide real quick, Simone, just with the main resources. So you guys can check them out, and maybe Tracy, if you feel like sharing these.
Yes, okay.
Sweet. So I think you guys can see my screen now, right?
Yes.
Yeah, so the main resources, like Simone was saying, is the docs. That's your best friend, is docs.iotex.io. If you want to meet other developers or also, be part of our community, I think our community is doing an amazing job. And you can check out iotex.io/discord. And Simone was just sharing the developers portal, which has some, pretty quick, immediate tools to get developing, setting up MetaMask, getting test tokens, etc. And subscribing to the newsletter, and that is developers.iotex.io. And yeah, I think with these three, you're basically in great shape. And you can always reach out to either myself or Simone on Telegram or on X. And we're always happy to help.
Okay, good. So we'll just jump into the Q&A session. Actually, at the end, like you have already covered one question. So there have another two. The first question is asking like, how does IoTeX process and optimize the interaction between on-chain and off-chain data?
Yeah, I think that's more or less what we have been showing today in terms of architecture. So let's maybe clarify it a little bit better, since someone is asking. So basically the main problem between connecting on-chain and off-chain data, main problems are a few. One is that on the opposite of what you would think, a device in a DePIN project is never going to send data directly to the smart contract, right? If you had one simple use case would be where the device has some sort of trusted identity that the smart contract can trust. We have some examples. For example, Pebble Tracker is a device that we created to prove this type of simple DePIN schema, right? Where the device has a trusted hardware identity that it's used to find the data message. And then this data message could be sent directly to a smart contract. The smart contract could verify the signature of the device, so trust the device that's sending that data, and then do something with that data. The problem is that DePINs are basically IoT systems, right? So they are fundamentally like they feature a huge amount of data volume and a huge number of devices and a huge number of applications. Multiply all of these, and you can easily understand that a blockchain cannot manage data incoming directly from devices. It would be too costly, impossible to store this data, impossible to process this data, and it's just not doable. So you need to understand how you can make a smart contract do something based on what devices are doing in the physical world, but still trusting what's the information is without the device talking directly to the contract. And also how you scale all this communication. And yeah, if you want, also how you make it private. That's another problem. Where you store all this data. And that's where all these like layers, how we decompose, why we decomposed everything into layers, and each layer should be decentralized and should provide one specific service to a DePIN application. If these layers are decentralized, and some can provide privacy, some can provide data storage, some can provide data processing, then the whole DePIN application can be trusted. So yeah, how we manage it, there is no like silver bullet to find a solution, how you solve the DePIN problem, but for sure, we are providing like state-of-the-art infrastructure and protocols. We have not talked about IOID, for example, that solves the identity lifecycle in DePIN. There are for sure many problems. We are trying to provide, yeah, like top-notch infrastructure and protocols to help DePINs to like at least start from something that is proven to work and to be secure, and then keep building on it.
Nice. Then last question. How does IoTeX ensure compatibility with different IoT devices while maintaining decentralization? Like, do you provide like any specific guidance or standards for device manufacturers and developers?
Yeah, that's actually a very good question. So while we are providing decentralized protocols, so we don't focus on devices specifically, we contribute a lot of research on the hardware side. This research spans from how to design an IoT device that is Web3 ready using, for example, TEs on devices. And this is all the Pebble Tracker side of our research. If you're interested, you can look into the Pebble Tracker documentation. Up to we are building what we call IO Connect, which is an abstraction layer for hardware. It's basically a library that allows to like provide a layer that is common to many different IoT platforms to provide all those features that are needed to Web3 devices, ready devices. For example, some cryptographic primitives, some decentralized identity features, some communication feature, all these like features that are the foundation for a firmware that is intended to interact somehow or to produce data that serves a blockchain application. All these like fundamental features, we have packed them into a layer that we call IO Connect. And this is basically a library that at this moment supports ESP32, Linux embedded systems, Nordic Semiconductor. We have a demo, and basically it's the foundation for like firmwares that want to like talk to Web3 applications and trying to abstract away the hardware layer from these firmwares. So this is one way we facilitate IoT manufacturers to create devices that are Web3 ready in a way that is portable and more like hardware transparent. Of course, it's still early development, but it's available. There are demos that show how you can create a firmware that, for example, implements device registration into our IOID infrastructure and how to use it to authenticate the device with its decentralized identifier with a server where it's sending the data. So there is a lot of development and research on this side. Again, no final solution, of course, but definitely we are contributing a lot. And well, actually, I'm taking the opportunity to share this latest, or is it? Is there a way we can share something maybe after? Is there a group somewhere?
I just dropped the link to IO Connect in the chat here. I don't know if like everybody can see it, but maybe Tracy, you can help out.
I wanted to share the latest research paper that I've not even read yet, but I was about to. It was released, I think, yesterday. The title is Towards Credential-Based Device Registration in the Apps for DePINs, which is another like article that we have released about the device side of DePIN, where we are researching how you can implement device registration for DePIN applications specifically. So it talks about basically using ZK proofs and DIDs on devices to make them more Web3 ready.
I dropped it in the chat. Okay, so I don't know if Trace, you have a way of like highlighting it on YouTube for everybody who's watching, or
yeah, I can just copy paste and drop it.
Yeah,
exactly.
Yeah. Sweet. And then I can maybe add the other links too, right? The Discord, the docs, and the portal.
Okay. Yeah, if there have any like new docs, you can send to me and I can drop it there.
Sweet.
Okay, so for now, okay, this one, good.
Okay.
Okay. Perfect. Yeah. So for now, I don't see any new questions coming.
Yeah.
So I guess,
but if you have, you can always share in the chat, and then we'll go through them. Maybe it's a good excuse to post something on X for everybody to read.
Okay. And thanks for the answers, Giuseppe and Simone. And today's, I guess, TinTin Meeting technical sharing session has come to an end. And thank you to the guests and all the audience for your active participation. I'll see you next time. Bye-bye.
Thank you.
Bye-bye.
Thank you. Bye-bye.